We're looking at homework from section 6.3. This is question number 11. A researcher wishes to estimate with 99% confidence the population proportion of adults who support labeling legislation for genetically modified organisms, GMOs. Her estimate must be accurate within 4% of the true proportion. A. No preliminary estimate is available. Find the minimum sample size needed. B. Find the minimum sample size needed using a prior study that found 79% of respondents said they support labeling legislation. C. Compare the results from parts A and B. So let's recall the values that we have. The minimum sample size formula. When you have a confidence level C and a fixed margin of error E, the minimum sample size formula is N equals P hat Q hat times ZC over E squared. And remember that if you don't have preliminary estimates available, you use the values P hat equals Q hat equals 0.5. So now we can look at part A. In part A, we have no preliminary estimate available. That means we're going to use P hat equals Q hat equals 0.5. The minimum sample size formula is N equals P hat Q hat times ZC over E squared. With a 99% level of confidence, the ZC value is 2.575. With a 4% error, we convert that to a decimal. That's 0.04 for E. And then the P hat and Q hat are 0.5. When we simplify the fraction, we get 0.5 times 0.5 times 64.375 squared. Squaring, we end up with 0.5 times 0.5 times 4144.140625. Multiplying all these numbers together, we get 1036.035.15625. And we always round up to the next highest whole number when we're finding minimum sample size, so this would be 1037. That's our minimum sample size for part A. In part B, we do have a preliminary estimate. The preliminary estimate is that P hat is 0.79. So this error formula is going to be 0.79 times 0.21 times 2.575 over 0.04. Remember that Q hat is 1 minus P hat. That's where the 0.21 comes from. And the 0.79 was our preliminary estimate for P hat. When we simplify the fraction, we end up with 0.79 times 0.21 times 64.375 squared. When we square 64.375, we end up with 4144.140625 multiplied by 0.79 and 0.21. That gives us 687.5129297. We go to the next highest whole number, which gives us a minimum sample size of 688. So now we're supposed to compare the results from part A and part B. Clearly, the minimum sample size formula found in part A was larger than that minimum sample size found in part B. And that's always the case. When you have a preliminary estimate, your sample size will be smaller than if you don't have a preliminary estimate. So, the correct choice here is answer C. Having an estimate of the population proportion reduces the minimum sample size needed. And that's your answer.